Sorry. We just wanted to show you the different issues we didn't have in sight, we didn't have planned for the hackathon. At first, the only real information that we had was the objective, just to inform the farmers on the environmental impact. And we chose to focus our efforts on the carbon indicator. And then there's three main issues that we didn't see at first. First, dashboard, the format that we had to deliver on. Then the data, because there was some data, but first, some of them was hard to find. Most of them was very difficult in terms of matching issues, because on one side we had anonymous codes for each farm, and on the other side we had field ID, and we didn't have the key to match both options. So it was really hard to exploit all the data we had. And finally, some data was in Dutch, that is not our native language, so a little bit complicated to understand and to translate. Finally, we had to define the message that we wanted and the associated KPIs. We had all the freedom, so even if that was an issue that we hadn't planned, it was great to have the full freedom of what we wanted to deliver to the farmers. And I'll give the speaking to Bastien on the data that we used.
It's like a fast overview of the data that we use. So the first is like the plant information. So it's all about the information related to the field itself. So we have some ID, we have the shape of the field, the crop, and this kind of information to compute some more index that we will use to compute the carbon KPI. The NDVI index. It's an index that is that provides an information about the density of the vegetation. So bigger it is, more vegetation we have. It's directly related to the carbon KPI. Then the soil map carbon. So it is data that provides the carbon in the soil, and it's one of the most important information to compute the KPI. So we find a map about the whole country, and then we are supposed to map it with our field to extract pixel by pixel references. By the way, the NGVI index is computed from satellite image, Sentinel-2 for 1 month. The carbon influx indicator is directly the KPI that we use. So it's like the information itself that the farmer have to improve. And at the end, we wanted to provide a target, but it was a bit short in time, so we did some computation that we can finish it. And we want to give to the farmers the possibility to compare their field to some other farmer, neighbor or other, just to see the potential impact of some action, maybe because the field are managed by a different way. So I think that for the farmer, it is interesting to compare to what is done aside. So, okay.
And now that you know what data we had, we wanted to present to you what we want to provide to the farmers, the messages, the key messages we want to keep in the dashboard that you will see a little bit later. So first, as Bastien said, the carbon flux indicator for the past years, for this year as a baseline, and even if we didn't have time to compute, we want to provide to them an insight of the future if they keep doing the same things as today. Next, as Bastien said also, we want to provide them with a benchmarking from other farmers on similar crop or similar geography. So they can compare it to each other and create maybe social links, and you will see that a little bit after. Also the target, we didn't have time to compute it, but we have the data, and the objective is to give them what you are now and what you can do best. And finally, we have a list of 14 actions on the carbon emission, and we are able to tell them, you have your baseline. If you put one of these actions, it will increase your impact on carbon. So you better not do any of these actions if possible. Finally, on the rewards,
So our aim is to provide a dashboard to the farmer to have a sustainable impact on their life. So on the perspective of profit, when the farmers are doing carbon farming, they will have incentives or reward from the government. And as study shows that the consumers prefer the products which are organic and also supports environment. So agro-food industries also will be interested in this product from the carbon farm. So their farmers will have increased income there. And as this is a carbon farming and in a long-term perspective, there will be increase of carbon in the soil. So farmers don't need to use a lot of fertilizer. So there will be reduction of cost as well. And in terms of planet, it will enhance the soil profile. It will increase the carbon content, and it will boost the population of microorganisms in the soil through this carbon farming. As part of our dashboard, we are trying to connect the farmers by field IDs because the farmers don't want to share their profile with each other at this point. So if farmer sees that this field ID is nearby him, and they can connect to each other and see what is he doing to increase his carbon index higher. So they can contact and they can create a carbon farming community in future.
2 minutes for the dashboard, guys.
Okay.
So it will in future there will be a sustainable carbon farming community. Thank you.
Thanks.
Hi. So to give you an idea of what we wanted to do about the UX, the interface, so we made some templates to show the information that we wanted to share with the farmer. So the first page is in Dutch, the next one not. So the main idea is to show to the farmer the geographic image of the different fields that he wants to see, and by selecting an ID to have the information about this field. So we have the perimeter, so and the area and the crop and everything. So let's switch to English. Will be easier. So about this dashboard, you have like the first information, and the most information is the CO2 flux, so the carbon indicator. You have to the vegetation density, so it's the evolution of the NVDI across the year. And at the end, we have like the similar fields. So it's the fields that have the same characteristic than the fields we are looking for. So with that, you can just switch to another field. So the second one we see there, and you have the information about this one. So you can compare. You can have information about all the fields, and you can click on the other field to have the information directly. With that, you can just evolve during the year. So the first information is about years that are already passed. So we have the real information, and you can see that we have another CO2 flux impact and another vegetation density graphic. So the last option is to go to the future. So we have data for 2023, so it's not happened yet. So we don't have real data. So the idea is to build a predictive model for the CO2 flux and to be able to estimate a new CO2 flux for the farmer.
Yeah, and to conclude, I just want to let you with an idea for the next version. We really think that being able to compare with the other farmers and being able to connect with them is the next step to create, as Paul said, the community, but also the farmers community to share best practices and give them help between each other.
Okay, great. Thank you, guys. We have time for one question per jury member.
So can you just give me a quick run through what were the data that you used to like give your predictive model?
So concerning the data that we used, concerning input data, we used Agro Data Cube using their API. So it was used for two things. The first thing was to make requests while choosing characteristics that we wanted to show. So the objective is that the dashboard will have afterwards many filters, so you can choose directly the characteristics we want. But for our example, we chose, for example, the crop, etc., and the zone that we wanted to work on in order to have a sample, to not have the full data. And we also used Agro Data Cube in order to compute the NDVI. So we made a request, and then we made some feature engineering in our Python notebooks in order to combine both. So we had the geometries that you can see here represented here, for example, and we had the NDVI, and we used afterwards the tool that was made available on the NIVA GitLab that uses the NDVI temporal data in order to compute the CO2 flux.
There's one additional question, Ludovic.
Yeah.
Yeah, hello, it's Eric from CESB in France. Maybe the song was not very good, so maybe you said it already, but I was curious to know how you used the historic data, soil data.
The historic data?
The historic data.
Maybe. The historic is the data on
The soil map.
Yeah, the soil map.
The fact is, you are supposed to use this. That was to compute the wanted CO2 flux, so the target for the farmer to improve their carbon impact. The goal was to just load the complete map. Then from the map, you just extract the region of interest for your field. You can do a kind of mean just to have the value for the field itself, and then you can include this value in the computation of the target wanted for the farmer. I don't know if it's clear or not.
Maybe you can. I'm not a soil expert either, but the thing is that we talked about with the NMI is that there's a particular you can measure in terms of organic matter. You can measure what of the farm that leaves the farm. There's models for the depletion in the soil. Yeah. So these three indicators, if you combine them, you have a balance for.
Exactly.
And this is what you found in the ISRIC soil data. Yeah. Okay.
Yeah, sorry.
No, you don't have to. We ran a little bit out of time. If you have an urgent question.
Yeah, a quick one. What I understand is this is all being done with open data, or at least public available data.
Yeah.
But especially, I think for the future, you would request some farmer data. Did you think about what kind of inputs the farmer should give to get your prediction in order?
There's a lot of inputs that we can use, from the simplest, that is just what crop they are, what crops, what time of the year they are farming. But also tomorrow, if we want to really enhance their farming carbon-free level, they will have to maybe just put the kind of pesticide they use to create a more thin indicator and compare to what the neighbor is doing. Does it have the same brand of pesticide as me? Is that why he has a better carbon impact? There's a lot of data that we can provide and ask the farmers.
Just to complete this, we were too short in time, but we wanted to.
We are actually short in time right now as well. So I'm going to cut out the stream.
Okay.
Thank you so much for now.
Thank you.
Thank you.
Can the second team for the dashboarding come to the front? Share it within Teams if I want to show something like this. So we actually didn't really prepare a complete presentation. We just have to. Oh, we did this differently. Where's that? This one. So we put one statement there. Why are we doing this? We want to develop a tool for farmers and by farmers to assist them into the needed conversion to circular agriculture. I didn't come up with this statement. While allowing data sovereignty and focusing on regaining trust. So it started from the farm data safe, so having a place for a farmer where he can keep his own data and have control over his own data. But if you have the data, then you can of course also visualize what is in that safe, and that's where the dashboard comes up. I'll switch to that one. Does this work? Oh, yeah, there it is. So this is the application, the farm data safe. This login should be then the safe part, but for now we have a sort of a mock-up and we can fill in anything. So it will get safe. So then the idea is that you, as a farmer, you can register your company. Sorry, it's all in Dutch, so that's. And this is also just, yeah, you would fill in some details on your farm in here. Also, this is just, yeah, 2 example fields. So it would be a name, something about the location, some things that are interesting to keep in there. And the main part is that you get your fields in there. And for this, we have an example. This is extra points live demo, guys. It's a bit of a slow one in Teams. So while this is loading, we have some performance things. Oh, so it is. So the idea is that there's kind of 2 levels in the visualization. So the first one is visualizing the KPIs at the farm level. At this point, we have, actually 2 indicators. The first one, the surface is not, we put it in there for the visual. We have the greenness, the annual greenness and the crop rotation index in here. And you can, it shows the values of the years that are loaded for this company. So that's to give a kind of the overview. But then you can also go into details to find out, okay, where do these KPIs come from? Which fields are, that's always tricky because then when you do it live, it doesn't work. You can dive into the fields themselves. Not now. So you can select, so you can see the parcels here in the map. You can select the fields for a certain year and a certain or a specific field, and then you get a bit more details on the indicators for that specific field. Yeah, and that's it for now. So,
in fact, we also have an online version of very basic front end. So, but yeah, we try to improve our front end. Yeah, what I would like to say, the application, our system is based on a microservice architecture. In fact, here our aim is when farmer run the system in his own machine, so he can freely add other services into the system. So thanks to this microservice architecture. And also we implement in a way that the system can be on our machines, on our servers, Kubernetes environment, or the system also can be deployed on the farmer machine. So we have also this flexibility. And overall, we want to give flexibility based on microservice architecture and plus safety based on authentication authorization. And also, for example, in case of sharing data, etc., so all will be checked based on authentication authorization mechanism existing in our system. All from my side.
Now we have Rob Klaver is going to talk a bit more about the indices.
Yes. So can you hear me? Hopefully. I see Tom waving, so that's a good sign. Yes. So like I was working a bit in the background on this with this team. So like Ilya said already, it's supposed to be a modular approach that the farmer can run on his own farm. It's supposed to be a bit more autonomous than a government-controlled system and a central database solution. Ultimately, we're taking steps on the way towards that, and it goes hand in hand with these farmer data spaces and all these developments giving farmers sovereignty about their data, more control. And also this approach where the farmer can add his or her own data to in this case, the KPI, these indicator calculations, to make the calculations more precise. And if the calculations are more precise, that could mean higher value of the actual indicator values compared to when it's only calculated based on open data or inaccurate satellite data. So that's one of the ideas. For now, these indicators that are visible are based on our data cube. So that's a big data warehouse that only has open data from RVO, and we add some processed data coming from Sentinel satellites, so Sentinel 1 and 2 at the moment. And some derived values. Most of them are statistics per crop field. Let's see what else. I did yesterday add this CO2 flux tier 1 calculator, but it's not visible in dashboard yet. Based on the NIVA calculations that are found on GitLab. So since we already had this mean NDVI time series over the year, it was quite straightforward to add that. Let's see what else. Yeah, just to say the development of the indicators. Usually, there's a concept, and we test them with farmers to see to get their feedback and further develop them in a kind of iterative approach. 1 minute. So they're really developed with the farmers and with farmer communities. So Boerenverstand is also included, I think, just to come up with something that actually is acceptable. Time out. Okay, thank you. I guess we have time for questions, hopefully. Somebody's speaking, I can't hear it.
Okay.
Yeah, otherwise I asked a question to the ladies.
Okay, good.
But you have this cloud edge dual kind of thing in mind. What does that mean for the data that is not coming from the farm? Do you expect farmers to download all these data and manage locally?
Farmer can upload, and also based on a-harkening, RVO can get data. And the system keeps this data. So then it's based on if the system is on the machine of farmer or in a centralized way. Yeah. But in both cases, so the data would be get from.
Okay, so it's either local or in the cloud.
Well, in fact, if the farmer prefers to run the system on his own machine, then there is no cloud. So it's in his own machine. So no connection.
Okay.
Yeah, and also just needs the farm specific data, so it's not. It's less in amount of data.
Simon, last question.
Indicators. So it wasn't okay. I mean, it's difficult to build the indicators, and I think you mentioned it. You know, that could be put together, but how can you? Yeah, given the data, I get the feeling it's coming from different places, different quality, etc. The indicators themselves, how useful at the end of the day would they be for the farmer? How can you make sure that they're going to be useful for the farmer? Because the indicator, what I mean by this, if you have all sorts of different kind of data coming in, you'll get all sorts of different results in the indicators, which your goal is not to make it comparable to another farmer like the previous.
In fact, we also have this in mind that different farmers' result also be comparable, but we don't have this functionality yet. But we had also this in mind.
But do you have any constraints on the indicators to build the indicator?
Yeah, probably what was more about the indicator, but the approach we are having is that we gradually build up the indicators that are tested and researched, and once they are okay, then we can put that add that to the dashboard. So it's like kind of building up on.
Correct me, Rob and Marlies, if I'm wrong, but as I understood it, there is a set of 14 KPIs. It's being researched in the added value of being something that we can compare regions to and different sectors to. So we have one common language in terms of what are the key KPIs for the Dutch agriculture. The main research activity capacity is within Wageningen University and Research. And the first type of object for the dashboard would be for farmers to get a clear overview and insight of how does my farm perform in terms of these KPIs. And then in the future, perhaps there's the ability to evolve and add and change.
Farms or to evaluate in a group level certain farms. So we are also this in mind.
Okay.
Okay.
Thank you, Rob. Thank you. Thank you, Rob.
Yeah.
Third team is the biggest team. I've asked them, with all your permission, I hope that's okay to be the last. So I want to skip, fast forward to strip cropping.
Okay. Yeah, I lost count.
I'm sorry.
I thought you had a second team also.
Yes, I did. Okay, I'm sorry. My bad. Okay. So we have the second team on carbon farming.
I will quickly set up. That's a nice, recognized.
Nice and green.
Nice logo.
Take it away. Okay.
Yeah. So I present to you the carbon challenge. We are with a team of people here locally and some people in France, Guillaume and François from my team farm, and me myself, I'm from Tracker Data, and we have some other support. So what did we set out to do? We meant to test the current tool of My Easy Farm, which is the carbon tool. And
can you speak up a little bit louder so it's
yeah. We did this like they've developed a carbon tool in France, and we set out to test it on a Dutch plot using Dutch data and see how that compares and whether it works. What's important to note is the My Easy Carbon tool is based on a NIVA model for carbon sequestration. Then to show it, to improve kind of the application of this model, we also tried, then we improve it with, for example, the machine data that my company gathers. And the last one, I would like to, oh, it's not going along, yeah. We would like to investigate, does this really lead to a significant effect in improved carbon credits for the efforts? So Guillaume will take over from here and explain a little bit about how we went around it.
So yes, hello everyone. So what we did concretely, you can see on the left image some data from the machines, so from tracker data, mainly related to the fuel consumption, and also on the right, the interface of My Easy Carbon, on which we are able to input data to estimate soil carbon sequestration and emissions of greenhouse gases. Can you go to the next slide, please?
Yeah.
So as a next step, what we could imagine is to integrate, thanks to API, the data from tracker data. So for example, here you can see fuel consumption from a machine that we could integrate, but more generally, we can have data from, we can try to understand the type of the operation and so on, which are really useful then to measure carbon sequestration and also greenhouse gases emissions.
Yeah.
So regarding the inputs, what we needed for My Easy Carbon, we have 4 main points. So the first one is crop rotations and some data related to the crops. So the yield, the moisture when you harvest the crop, the residues are exported or not, and so on. In this case, in this field, we had like 2 years grassland and a fodder bit. Also, we need soil analysis, a soil sample for the baseline with a soil type and some information related to the soil. So it's really important to make the baseline, and also some weather data that are needed into the soil carbon storage model. And finally, for the greenhouse gases emissions, we need the operations, which are really useful for the modelization of the fuel emissions, but also we can have some information on the yields coming from the harvesting operation, but also if they are fertilizers or not, and so on. But in this case, we are only 4 different operations and no fertilizers. So for the My Easy Carbon method, it's based on a modeling approach. For the soil storage, we use mainly French calibrated model, which is the IMG model. And on the emissions part, we use, so according to the French low carbon label method, we use mainly IPCC 2019 algorithms. So yes, for the baseline on the soil, we use soil analysis, soil sample. And also here we can see for the fuel, so on the 2 images you have on the left the soil storage and the carbon storage in the soil evolution on the time, and on the right you have some graphics, so it's quite small, but we will explain later on the emissions on the plot on the field. And in this case, with My Easy Carbon method, we are using a modelization of the operations. So we declare the operations on the tool that allow us to estimate the fuel. So the liters of fuel for each operation, and then the emissions related to the fuel. But in this case, we have to apply 5% of discount take into account the uncertainty of the data. Can you go next, please? So yes, just to sum up a bit, so in the tool we need some input data. We use so mainly weather and soil data. We could use also, as in this example, some data from the machines coming from tracker data. Also, one thing which is also really important is to combine satellite data. We can use satellite data as an input because we need the information of the crop type and so on. But also, it's really important to monitor the project and the operation. So also, we could use the remote sensing. And also, we are currently trying to work also, and we hope to integrate SAFI CO2 model from SESBio by the end of the year, which will be really useful also to monitor the biomass and the CO2 fluxes. That could be useful in different certification framework other than the French low carbon label. For the soil model, we use in this case the IMG model, Simios IMG, but also Oki told me that in the Netherlands, you are working also with NMI on a soil model that could be maybe more adapted to the country.
This carbon model is exchangeable, basically. So for the machine data method we used, I will explain a little bit more.
4 minutes.
Yeah.
Okay.
We went side by side, so we run the model through the MyEasy Farm, and then because we already had the machine data, we could at least calculate part of the emissions, part that comes out of the MyEasy Farm tool by hand, just calculating going from the fuel that is consumed that we saw in the operations. And this is interesting because we saw a difference with kind of actual data versus assumed data with a factor of, okay, we assume if this crop has been planted, then these operations have occurred, and then we assume so much fuel was consumed. So we can do a guess of the emissions, but in reality, we came to 142 kilograms of CO2 per year, which is different from what the tool was suggesting, which is 233. And yeah, so to conclude a little bit more into our findings, if you want to improve the accuracy of the carbon models, there's also some limitation in the model underlying these tools, because they cannot account for the, the granularity of specific types of data. And this is kind of a chicken and egg problem, but it is something important to notice, I think. Like we also found, we can model things both ways with actual log data and modeling. So here are again the differences in fuel emissions, and there's 90 kilogram less than modeled. Some considerations that go with this are there's some uncertainty about the plowing. We do not know for sure if the activity we saw was the only activity on the plot, because there might have been a contractor plowing. But assuming this is, we've captured the whole circle, because the farmer used to do most of the work himself, we see quite a big difference. And the same thing goes a little bit with, you have to run the whole farm with logging equipment to get full coverage of these people.
Last slide.
Yeah, so almost the last slide. Guillaume has some comments on this.
Just 2 comments, yes. So when estimating carbon credits, we make a comparison between the baseline and the project scenario. So we really have to monitor the changes in practices, and a higher precision for input data when we don't have any changes in practices have no value for the farmer regarding the carbon credits generation. And also, we are mainly speaking about fuel emissions, but on field crops farm, it's about 60% of the emissions that are from fertilizers. So actually, from fuel emissions, it's quite a little part of the emissions of the farm.
Over what's the financial result for the farmer?
Good or bad?
Huh?
Good or bad? Even. We're gonna have to do it with that because otherwise we're really gonna run out of time. Some.
Yeah, well, this was basically it.
But leave the other slide on, so the one we're asking questions, we can read it.
Questions for the jury?
Yeah, you talk about carbon credit, but I seem to see the focus was on the fuel, and there was a mention there by Guillaume, just of the fertilizer. So this is emission reductions, or you're actually also seeing carbon being sequestered, or maybe not sequestered, maybe even being released in the field?
Yeah, what's happening is the French model accounts for both capturing carbon, but also emissions. So this is the French low carbon label, basically includes both the outputs and the reductions.
Yeah.
And this is somewhat different from what we have in the Netherlands, as in we don't include like fuel emissions. But this is, yeah, how do you say? For a total balance, you would have to make up.
So the model does both. For the aim of the hackathon, you kind of focused on the emissions by fuel and fertilizer.
Yeah, because these are the ones that we had good data for to check.
Right. Okay.
I wasn't quite sure, but I have two questions. Did you use the tracker data only for the fuel consumption, also for monitoring what activity was done where at what time?
This is in the data, but we're still working as a company on making it properly searchable. So it's potentially in there, but now for the sake of time, we focused on, okay, let's take the fuel as a good example because we see directly output in the model and we can easily compare. And the impact on just the fuel part is quite significant because it was, they say it's 40%, but it's 10% of the total that comes out of the carbon flow in the year.
And the second part is, could you use your system to advise farmers what scenario is more likely to sequestrate more carbon than the other?
It doesn't do forecasting, but having a good view of the inputs, like, okay, just driving with my tractor all the time to the field is consuming this much fuel, and also having a field far away is kind of a carbon intensive practice is also something to be aware of if you're going to be a carbon farmer.
Right. We have one.
And to complement the answer, so yes, we can simulate the different levels of changing practices by the farmer. We can simulate that and make calculation of what will be the impact of implementing reducing tillage or adding an intermediate crop or so on. And then as a third step, the tool can then monitor in detail what was done in the field to make real calculations with real data.
Thank you.
Peter, you had a question?
Yeah, in this line with the 60% coming out of fertilizer, I expect that is artificial fertilizer, so CO2 which is fixed to make fertilizer. Is that not? It's not organic fertilizer.
You're right. It's so regarding manual fertilizers, it's also upstream emissions. So for the manufacturing of the fertilizers.
Yeah. So if you replace this with manure, then you would have a tremendous effect, and you could calculate such an effect. You could say yes. It's so much when you do this. That's really interesting.
Yes.
Thank you.
Peter, in terms of time, I want to finish here. Thank you, Team Carbon. Can I ask the team for strip cropping to
Go to the front.
Common challenge. The easy farm.
Are you set, Julia?
What's the name of this team?
Okay.
AI Geotag, that's the final one.
Okay. Okay.
Mark, the clock is ticking.
Already. Okay. So we're the team on strip cropping. We have all these nice strips here. We're a mixed team from Italy and from the Netherlands. Our main challenger, Luca, is currently in his house in Italy, so he can't present this part so very well with the bad connection, which has been troubling us a bit. So I'll do the first words. So this is the team. We can go to the next slide, please. So the thing what we want to do is to help farms, especially in Italy. There, Luca has placed the problem that in the Italian setting, strip cropping is something of a difficult farm practice, which payment agencies can't seem to handle very good, which is obviously very sad because strip cropping is a very good farming practice, which we think is very promising. In the Netherlands, we're doing many things. This is Farmers' Future. We're doing some tests on this, and also Luca in Italy is doing the same for his farm practices. So we want to help the farmers to go and do the strip farming and still get paid the subsidy what they should get. So next slide, please. Yep. So actually, we made a flow from a few steps from components. We want to use geotag photos. We want to process them, and we want to make an interface with the PA, that's the payment agency. But maybe the next slide would, yeah, you went the wrong way. Yes, this one. So what we want to do is, this is more or less of a data flow. We want to make use of the multiple data sources that we have available, geotag photos, but also imagery, which may be very coarse, but still we think we could look at it and try to make sense of it. We want to process these things in a calibration algorithm. You always have some parts which won't be able to get done, and then you have to set it to the payment agency, and then the other flow we could send it to the click and pay system, and the farmer could get paid his subsidy. So I think the next one is the mock-up, and no, the first one is something about the. Can you tell you something about what you have been doing with the Geotag photo app?
Yeah. So initially we had a plan to work with an existing Geotag photo app, which is used a lot in the field as well. It's called QField, which also has cloud connected to it. But in doing this, we noticed that there were a lot of problems we ran into with interfacing with it, and we couldn't get it done in time. But we feel like this might be a solution in the future to use, since it provides a lot of functionality that's also needed in our app, which is already existing. So it might be interesting to look into that in the future.
Okay. So the first step, the photo that was done by Ty. The next one was Marcel was looking at the algorithm, how to classify the
exactly.
data.
No, actually, I cannot take the honors here because it was Luca Benzi who did the work. I tried a lot, but it didn't work. As you can see, this is a Python notebook file, and Luca started with this image. But for a computer, this is way too little to process, yeah, because it has so much trouble with all the noise that is in the picture. It cannot tell whether this is strip crop or not, because that's a central question we would like to answer. And if you can go down, Luca did a lot with segmenting, so you take away a lot of colors, and then you can see some surfaces, but still a computer cannot compute with this. So then go down, go down, go down. He did it with grayscales, and then some filtering was done, like blurring and also sharpening, but still that does not do enough the trick. And then finally, I make this really exciting. Some other ways of processing the data.
This is amazing.
And yeah, it's amazing what Luca did. And a little bit up again. Yeah, and also here it's still not there. Up again. Yeah, and here he finally found a great result. Here in the top left, you can see actual areas that tell the computer here is strip cropping taking place. Because here, the computer can recognize. Yeah, because these are large areas. It's not strip cropping. And these are small areas lying next to each other. So finally, the computer can recognize now the strip cropping. Luca took it a lot further. He went also into machine learning, deep learning, and even did 35 iterations over it. But it looks like this one is the best result we have until now. And then we only, and what is nice about it, it does not only look at the pixels, but it also looks at the colors. So it takes two sources of the picture into account in order to find the strips. So great job, Luca. Luca Benzi, that is.
Yeah. So that gets confused. We have two Lucas in our team. So we are lucky.
I was thinking, this guy with Corona, he just.
Yes.
Okay. Fair.
So okay, yeah, and that's the next step is what we can offer to the payment agency to functionality to make sense of the things which the algorithm would maybe not make sense of.
So that's where we made the mockup for. There. What you see there is a satellite image overlaid with the lines that the farmer put in about where his strips are. You see icons for where the photographs were taken with the app. And then for the application, the person from the paying agency can check the pictures and basically validate whether those whether that field has actually had strip coupling applied to it. So yeah, that's basically that functionality. You can see click on other pictures as well.
Maybe that's also good to say that you could, as a payment agency, say what kind of requirements you add to your data. Do you want one picture? Do you want two pictures? These kind of things. You can see it on the screen, and you can judge if there is enough data to go further in your process of dealing with this application. Yeah.
Yeah, and then there are ways if you click a strip that you can measure it, see how much or how wide it is, and then eventually, you can actually also see the Sentinel picture, the Sentinel-2 picture, and afterwards.
Even it's good to see, even if you have a Sentinel picture which is 10-meter resolution, you can still see that there is something going on which is not a whole field. So you can use this as information for judging and validating if there's strip cultivation done.
Oh. And then eventually the person from the paying agency has to validate. Say, well, was there strip cropping applied? Yes or no? And maybe answer some more questions, which still have to be defined. But are the strips between 3 and 24 meters? What crops have you seen on the pictures? Those kind of questions.
So been working on this complete flow to deal with this data. We haven't done everything what we wanted to do. Well, but like we said, we've looked into the functionality of the app. It was something which we need more time than a day and a half that we worked on it. We also looked at the Irish NIVA app that seemed even more difficult to get running now in a short setting. So this could be done. Yeah, working on the classification, and we already seen very nice things being done. We could still go on with some extra iterations, and oh yeah, that's something which also was said by Luca. They say, okay, you have a nice flat country here with this nice flat data. In Italy, there would be some problems that the parcels would have and the strips would have a bit of other shapes in hilly conditions. So
we have hills as well.
Oh yeah, we do. So
time is up.
My time is up.
Yes.
Well, that is too bad because after the hackathon we still have
1 minute
challenges.
to go. Yes.
Well. What we have been thinking, we have made a first attempt to show what is possible, but the next step should be to collect Italian data and to try to get it in an Italian sense and then present it to the payment agency so that they can be convinced that this is a way to go and that the farmers could be rewarded for a very good activity, which is a very good plus for the biodiversity. So that is for the next steps. That is it.
Is the machine learning Luca online?
Yes.
Yes.
Yes, I'm here.
Well, maybe some final words from your side.
Yes. We used a model algorithm without artificial intelligence because in 2 days it is impossible to training a model. So I try to implement an algorithm with a heuristic algorithm, so without intelligence, because we don't have a GPU. I think we need to field segmentation of the field, and we have to classify everything. The problem is the image. Image high resolution is too difficult to collect. And we have to use Sentinel-1 and Sentinel-2. So for this type of processing is not too easy, but it is possible. After
Luca,
that,
Luca, do you want to share your code?
Yeah.
Yeah. Okay, great.
Just a moment. Okay. You arrive here, and this is the one method, and this is a good approach, but is not the best. After that, I try to more in deeper and find a solution with some iteration, like to 35, the first, and we find some border. But after more iteration, we can find a better solution, and you can find a different pixel, color pixel. So after that, we can find all border, and you can find the different type of field. And in this case is optimal for our type of problem. So we can find the difference between one pixel and the other pixel. So I think with this solution we can tell if is strip cropping or not.
2 short questions from the jury. Thank you, Luca.
A short question, but maybe a longer answer. So I'm working on the basis that there's an extra payment for the farmer because of the strip cropping. So therefore, it's basically a verification of that. So you ran segmentation, if I understood, basically on one image, but you talked about different images. Is there a way that you think maybe you could combine the different images to enhance the way you do the segmentation?
I think Luca is the one to answer. Did you get the question?
I can't understand because there is a noising. But you can train in this model with
I think the bottom line of the question, let me try.
Again, if you
is there a way to use multiple images as the basis for your segmentation?
Yeah,
different types of imagery, I should say.
Yes, of course. We can use a different type of images. I use extension JPEG, but you can use everything to apply to segmentation. It's better if we use an approach with deep learning or machine learning, but we need more time and more image and the labeling of the image. So in 2 days is impossible to do it. So I can try to approach a different approach without artificial intelligence.
Thank you. No, did you want to refine the question?
No, actually, exactly the same question. Well, maybe one small thing, because I think the challenge was also to prove that strip cropping was contributing to biodiversity.
The challenge.
You didn't take.
Well, when we were working at the start, we refined the question, and Luca said, focus on the exchange with the payment agency, because the biodiversity part is very science based, and well, that part he's covering with his project. He has his Horizon 2020 project, and the other part is more interesting for him now. So we make the focus on that part.
I don't know if you can comment, but then the question would be to Luca: are you satisfied with this type of data analysis to feed your model for biodiversity? Luca Colombo.
Yeah, I'm definitely satisfied. I'm very grateful to my colleagues, and I apologize for the conditions they had to work with me. I just want to, I think it's very promising. My just additional comment is that machine learning can be fast. It's not immediate, as the other Luca said, but it can be fast. Institutional learning will take a longer time. So we will also need to work in that direction in order to adjust procedures accordingly and make strip cropping fully eligible in any conditions.
Thank you.
Thank you. So we are running a little bit late in time, but bear with us, people online. We have a final team. Challenge number 3 on geotagged photos and AI. Let's give him a little bit of time to set up.
Excuse me, so just a small amount. Our website is not online, so we fix the issue and we deploy it. It is farmds.org. So you can also test it on.
Can you put the link in the team?
Yeah, in the team. It is farmds.org. Yeah, data safe. Yeah, farmds.
We'll pull it up after in the meantime.
Yeah, in the team already.
Are you ready?
I think so.
Go!
We have a big team. Reminder what our challenge was. So use AI on geotagged images. So the idea was to identify and analyze the data captured with geotagged photos and enhance the satellite images with that. But also make decisions based on what do we see in these images automatically. So basically, currently, what they also showed is humans can make decisions by looking at an image. Humans, they got time, and we want to not have the human out of the loop, but at least make some jobs for the human easy, which are easy. For that purpose, we developed this solution. So basically, this stream already exists. So we have satellite images in Ireland. If the satellite image is not clear enough, they ask the farmer to, with their app, make a picture. The picture is created, and an expert is looking at the picture, and this picture can either be taken by the farmer, inspector, or advisor. So what we suggest above sort of this normal workflow is to have an API where you can send the picture to. Basically, that does first classification. So we'll tell something about classification. Afterwards, it does quality control. If your picture is not good, either an expert cannot judge it or a machine learning system cannot judge it. So that's good to have. Then basically, we have looked into how can we sort of feed it back to sort of the satellite images. So that's the third step. And finally, it's demo time. We're going to show that this API works.
So yeah, to conclude or to proceed, yeah, we sort of ran into the grand problem of machine learning that, of course, we did not have enough data or photographs to train our models on. So we needed to dive into some solutions to overcome this. Of course, there's many solutions to these problems, but like there were certain time constraints. So the initial idea that I did a little bit dug into was like just looking up images that looked similar to the images that we were provided with. And also I tried to train models that tried to pick up the patterns that were in the photographs that we had, and in order to be able in the end to predict or to generate images that looked similarly, but in the end we just applied different transformations to the images and alter them a little bit in order to have more data to train our networks with. And yeah, this seemed to have been quite fruitful, and my colleagues then picked up on this and then did some modeling.
Yeah. So the dataset is subdivided in 4 classes: the pasture with scrub, the pasture with rush, the clean permanent pasture, and the arable emerging crop. Okay, we built and trained the image classification model using ResNet. It's a quite famous image classification deep learning method. And as you can see from the confusion metrics, the model was quite accurate. And also here in the examples, we can see that the green are okay, and the red, only this one in the 16 example, yeah, is not okay. But actually, the problem is about to differentiate from pasture with scrub and rush, because actually they are really similar.
So to give feedback, to improve the user experience of the farmer and to increase the image quality, we advise the farmers by giving feedback on their images taken. We have implemented a deep learning system that quantifies image quality, which takes into account factors such as brightness, contrast, color, sharpness. The score is calculated between 0 and 10. So on the left, you see the original image, and to the right, 2 overexposed images and 1 blurry one with decreasing quality scores. Related to image quality, because we're interested in land cover, we don't want to have pictures with a lot of sky. So we implemented sky detection, so we can flag these photos. It calculates the sky ratio, so the number of pixels with the sky, and the paying agency can set the threshold to flag the photo.
Okay, this is a quick overview from a remote sensing point of view. We had just 17 parcels, but 200 geotagged photos, and not all the photos are linked to the available parcel. parcels. We try to create maybe with a buffer an area just to extract the NDVI, for instance, also for the points that are not covered by the geometry of parcels, but it was hard work for in this short time. And in the plot, we can see the distribution of the classes that we had in the Geotag photos dataset. And we try, we don't know actually which is the model that has been used to extract the classification that has been performed and that leads to this classification. But we try to analyze the NDVI event series and for the different classes, and we notice as expected that there is a big problem of high cloud coverage. Those are plots of aggregated NDVI trends for each class, and we can see that there is a pattern that can be detected, for instance, for the arable emerging crops. So if we analyze the time series and if we analyze the phenological cycle, we can detect the exact point where the crop is emerging. Last picture, maybe, okay. And we can see in this picture is an example of a permanent pasture with rush. And inside this parcel, lots of photos were taken, and we can see, and we suggest to do so. We can see that there is a sort of pattern inside the parcel, and maybe we can consider the time series of texture features, for instance, in order to get this pattern.
So, in time, we are going to show the API we have made for this poll. It's working on both laptops. He's going to show it, so we will switch screens now.
Okay. So this is a single-page application. The nice part of this application is that it's already ready to be deployed on the cloud in any kind of technology, microservices, Kubernetes, or whatever, any kind of cloud provider is already prepared to be ready to be deployed as a user interface and backend system. So from here, we can choose an image. This is the dataset we were able to obtain for this hackathon. We just select an image. So it's my own laptop, so requires a little more. Meanwhile, it's processing. I can show you some results of our pictures. So, for example, here we can see that the average of the quality of the images is around 7 most of the time, and we can see that our score for the sky is pretty high, 9, and that means that it is a good picture. To explain these scores, the image quality is a score between 0 to 10, where 10 is the best and 0 is the lowest. For sky detection, 10 is in the picture there is not a lot of sky, so it's a good image, and for 0 is a full image of sky. And I didn't show you which class this belongs to, but this is, for example, I don't remember right now the label. Sorry? Arable emerging crop. And we use this kind of chart to express how the model is performing. At the moment, it's performing really well for this class. We will show you some other images, but it's not going exactly as this one. Same image. This one, again, the sky portion is not a lot, and so we have a good score for sky. As more sky is involved in the picture, we can see that affects actually the classification of a type of terrain. And so we introduce more noise. And here, probably we would ask to retake the picture because there is too much sky. And maybe it can be improved. And the same here, again, it's less evident, but we have some noise on the classification. And we notice also that, of course, reducing the image quality, this image contains a shadow, is blurred, overexposed. As you can see, the image quality score is reduced, and again, still we are able to do so, but was a small amount of data to train on. So anyway, here is still not super perfect classification. And we have a small problem for sky detections. When the quality image is pretty low, our algorithm thinks that it's all sky because it's a little foggy, so maybe it's confounding as a cloud. And but still, the classification is still working in some way. So we can adapt some policies depending on the image quality and the sky presence in the image to ask the user to take a picture or to refine better the classification. Let's see. Meanwhile, it worked. Okay, this is the image I selected before, and yeah, it worked. But no demo effect at the moment. And that was about this dashboard. So I can give you the screen again, Bas.
I think our solution showed out what it was going to do. It was going to be an API, so it can be used with other apps. So it's flexible. We can. So currently we didn't do that yet, but we can load in other data. So we can also provide certain strip cropping or other kind of crops in this app and classify that. So the data can be free, so it can be transparent. So our governments can explain where they get the data from, which is, I think, required nowadays by the EU. And yeah, as you've seen, it's easy to use. One button, you have a classified image. And maybe for the future, what we are seeing is it's nice to share this data. And actually, if farmers share this data, they get on the map also their images. And it's a very powerful story farmers can tell around, hey, I'm trying to do something interesting. I'm presenting data here. Look at this. So we think it's good that farmers can share. It's up to them, but it is shareable data and it's understandable for humans. What am I doing? And oh, this looks like this. So I think that's another big sort of cool thing which we can do in Google Maps in a view that farmers at least can show off. Another thing is this data has also a research impact, which can be used if you collect this data. So that was it for our pitch.
Wow. There is a question from the remote from Italy. I want to start there, Luca, or is that an old hand?
Yes, I have a question. Sorry, but I have the echo. I don't. Okay. You training this model with how many picture, and the training model is only with picture, or you used something like Sentinel-2 ensemble, a method, because I don't understand this type.
The number of images was 200, and we augmented to 1,000, yeah, and we used only Geotag.
Okay, with 1,000 photo, you training, you used an ResNet, so pre-training model, and you obtaining this type of result. Really, the confusion matrix you can turn on the computer.
Actually, if you want the details, we use ResNet 34, and we use 90% the images train and 10% to validation. That's what we.
Right, thank you.
Thank you, Luca. Jury, are there any questions from your side?
Yeah, I didn't pick it up, but maybe that's also the bad time. But was there any kind of, what's the context information that you can have associated with the photo? So you know where it is, but you know the direction, the time, the.
So currently, I think we had the challenge that the app of Ireland, maybe we did it wrong, but currently it seems that we only have location, but we don't have direction.
Yeah.
And that is also still maybe a little problematic because so if you are in sort of the edge of the field, you're not sure if it's that field or that field.
Yeah.
And of course, you know it by that they want you to point to that field.
Yeah.
But the data needs to be more mature in order to do all these kind of linking.
But could it be kind of incorporated in the way you're doing it? I wasn't so much where you were able to do it, but is that something that could?
Yeah, we believe so that if we start talking to the developers of the app, we can make a much closer collaboration and provide a much better experience for the people taking the pictures and stuff like that.
Before we go to Tomme, if I'm correct, Christine from Ireland, you are remotely listening in. Is there any thought that you would like to share or any comment?
I'm sorry, but I had a connectivity issue during the presentation, so I didn't get all of it. But you know, what I did see was very promising. It looks really good, and yeah, we'll follow up and have a conversation after about it. So apologies, I did miss part of it, but you know, what I saw was very impressive.
Thank you, Christine. No worries. Tomme.
Yeah, I'm thinking, is there a way that you can use the database itself for validation of your model instead of training it with a pair of eyes that say yes, this, that? Because if you collect 1,000 or 10,000 or even more photos of emerging arable crop, then the 10,001st one that is grassland would fall out on that set, wouldn't it? So you partly, I'm not sure if I understand your question correctly, you partly need training data. But at a certain point, if you have training data, then the app does the rest of the classification. And actually collecting the training data, often anyway, the ministry has inspectors who make a picture and write down what kind of farmland it is if they have doubts. So that is actually already for a ministry almost an automatic way to create this training data. So currently we got it from Ireland, the training data. We didn't have to make it ourselves, but I don't think that's the biggest problem. Let me rephrase my question. Before you send out people in the field, you first have this classification based on satellite data.
Yeah.
Saying, well, yes, we agree with this field. No, we do not agree, or we are in doubt. And yeah. The doubt cases are sent to the field. But you have the ones, you could also send people to the field that you are not doubting, and then use those pictures as.
Yeah, but so what we understood from the Irish partner is that the doubt cases are things they can often not see on the satellite. Like in the Netherlands, strip cropping, it's still like we don't have a model for it or we don't know. And here in this case, you had three sort of kind of grasslands, which are in their model very hard to separate.
All of them, always.
Yeah, or that was what they were telling us. And we showed that, given our data, she showed that, yeah, you can do it. It takes a little bit more time. And you need then to have more geotag data in order to sort of get this feedback.
Okay, I want to stop here. Oh, no, I don't want to stop here. One final question. No?
Oh, okay. Excellent job, guys. It was really complete. I just have one question. Could we maybe imagine, instead of asking people to retake photos, maybe to make some, I don't know, image engineering, maybe to crop the sky from the photo or something like that before starting the classification?
Yeah, that'd be possible.
This is a good question. So about the sky, for sure, the problem is not that the sky is present in the picture, but we have a lower resolution on the field. So even if we crop the sky, in general is probably in that case, specific case, would be nicer to we take a picture because probably the phone is direct into the horizon instead of the field. This was one of the ideas. For brightness or sharpness, something can be done, of course. But for the Skype, for example, I'd like to ask anyway. But anyway, these kind of policies should be agreed.
Yeah.
Okay.
Okay.
Experience and feedback from the customers.
It's 2:30. We ran a little late, but we are very lucky. We have a very fast jury. They are fast thinkers. They won't have to think so long.
Put the pressure on.
I'm going to take the jury out. We'll be back in about 15 to 20 minutes, and we'll have the award ceremony. So take a drink, cool off. It's quite hot in here. I'll get up here.
Okay, can I have everyone's attention? The jury is out.
The jury's in.
The jury is in. And they're coming out. One jury member is missing.
Half the jury is out. But maybe waiting for Tamara, just start with a little general thing. Is everybody? Tamara's back. Okay. So Tamara can start.
Where's the jury? Here's the jury.
Really, I just need some to smear my throat. Huh?
Yes, we are all. So as jury members, we have Tama and Simon. We were familiarized with Simon yesterday. You did the keynotes at the start of the hackathon. Thank you very much for coming here all the way from Brussels. Tama is actually head of many things. I'm not going to even try. Who are you?
See my LinkedIn page, right?
He would have been the head of the lead of the Kapiti conference that would have taken place here. It's been postponed.
11, 12, 13 July, you're all welcome.
Thank you for being here as well. Yep. But we're all very curious to your findings. Take it away.
Our findings. Right. Well, first of all, thank you all very much for your participation, your braveness in presenting your work that we've done in such a short time. We were really impressed, I think, with all the things that we saw and all the good and beautiful presentations and demos and live demos even. That's really challenging and really good. So we had a number of things that we were supposed to look at, and that was originality, how special and outstanding your presentation, your work, your project was. The feasibility, of course, is it something that could end up in real life, so to say, in operation? How good was it working at this stage? Yeah? What did you deliver? Was it just a PowerPoint or something more? Those kind of things. What kind of data did you use and apply? I think there was some data provided even up front. Did you use that? And also, we looked a lot about your presentation. How did you perform? Was it convincing? Was it? Were you confident? Those kind of things. Were the pictures nice? The organization told us we have 3 prizes to share. And I will do the prize number 3. So that's the first one on the podium, the first one on the stage, right? So not the runner-up, but the runner. I don't know how you call it. Number 3. So we decided to award the prize number 3 to a team that showed a very high level of IT technology, a high level of braveness as well by presenting a live demo that failed. But that's also, I mean, that's what live demos are about. It should fail, otherwise PowerPoint would not be invented. And a team that, to our thinking, had a lot of interesting points to delivered. Now I have to look at my data. Well, I think I can say it's the farm data safe team. Congratulations. Of all the scores that we gave you, I think what is outstanding was I like very much this cloud edge diversity thing. Although I think there's still some work to do on what do you do on the edge and what do you do in the cloud and how does it work together. But I think the thinking is very important because we know, and presumably you know that as well, the whole debate about data sovereignty in agriculture is a very, very big thing. So offering the opportunity to do some parts of that at home, isolated from the rest of the internet, that sounds like an interesting option. We have the Data Act coming up from the European Commission soon that will regulate a lot of these kind of things. So from that point of view, I think you did I don't know if that was intentional or not, but that was definitely an interesting point.
Okay, can I ask you to come to the front? Can you stand in front of the?
Yeah, I was. Where was the
middle? So can you stand next to her?
So you got the prize award of third place. Show it to the camera.
What is the third prize though?
Yeah, Vies, maybe you want to say something about it. Are you sure?
You want me to tell that?
It's gone.
The third prize, what? I'll say it's a €50 voucher per person. Yeah, that's the third prize. So congratulations.
Thank you.
Okay. I also say big thanks to everybody who's come and spent 2 days doing this. For me personally, it's completely a different kind of community to be kind of working to be in, and hear you talking about what you're doing. So I mean, I spend all this time writing all these rules and stuff like that. So to come and actually see you guys trying to work out how to make things operate in sort of this kind of reality, it's really, really interesting because it makes me reflect on what actually we end up doing and what the consequences might be. So I've been looking at the way you've been doing your projects from a bit more of the policy side. I mean, a long time ago I did technical stuff too, and stuff on segmentation and stuff like that, and image processing. Yeah, look at my LinkedIn. But that's a long time ago since I stopped, so don't ask me to really do anything on that now. But no, so it's really, really nice for me to know that you guys are enthusiastic to try to put in place stuff that really moves what we're kind of do for climate and everything forward. And so that makes me go back to Brussels with a real positive feel. So, okay, second is we're going to do 2, 3, 2, 1. So that's the second place that we chose. We looked at one, and from my perspective, it's also something really policy relevant, obviously. And I think the fact that it was a very complete project, that it pulled together processing from different kinds of things, and also like demo in it and so forth, these kind of features that we found pretty important. We definitely think it's feasible to go that way, and we think it can be rolled out, and that the use of the data was also, in the circumstances, really the right way. So this is the Geotag photo one. We can really see this fitting actually into something in the future as well. So they're supposed to come up to the front.
They are supposed to come up. The AI Geotag team, please, guys.
AI Geotag team.
We have one missing.
Okay.
And can join.
Yeah.
Okay, guys, congratulations. Big applause for this. Second prize is €75 per person in terms of Amazon voucher.
Thank you.
Thank you.
Thank you.
No, I do want to know whether we come back to the floor.
Yeah. Well, then I will start.
So don't worry, because we're going to give a little bit of comment on everybody. So this is number 1 now, but we will come back to the other 2 projects as well. So bear with us. But there has to be a number 1. Somebody has to win the top prize. It's like that in life. And this one we were really impressed that we thought it was kind of really on the topic at the moment, that it tried to make use of different data sets. I think also the team was trying to work in a new context, quite unfamiliar with things, I get everything away. Also had some language issues that they had to, challenges that they had to deal with. So yeah, the Capgemini team who presented at the beginning, we want to give them the number one because we felt that that was the roundest, most complete project. So Capgemini, I don't know if that's the right name. What's the name?
Capgemini antwoord.
Yeah.
So here we comes, number one.
So the number one prize is 100 euros per person in terms of a voucher.
Thank you. Thank you very much.
So 3 to 1, that means that we have a number 4 and number 5. Honestly, when we compared our rankings, the differences are not extremely high. So everybody had been participating and delivering on a really good level. But as Simon said, I have to make a joke every time. You know? There has to be a number 1, 2, 3, and also the other twos. So from the other twos, one of them was the strip copying team. We very much liked the concept, originality was really great, definitely different from the others. Although, and as Simon said, look at this LinkedIn. Some of the work that you've been showing has been doing, people have been doing that for many years. And the issue is always resolution, issue is always object recognition. So it's an ongoing thing, it's still there, it still needs to be done. Nevertheless, it was, I think, a good, very good exercise and very good presentation. The reason also why we thought you were not one of the prize winners was because it was not going towards the goal of the challenge. And I understood you rephrased it. That is, yeah, that's yours. Yeah. Sorry, but there's definitely a lot of potential and a lot of interest. I think biodiversity and carbon are two things that are can join together a lot. And so biodiversity is definitely an interesting part. And nevertheless, an applause for the. Do you want to add something to that, or shall we go to the last one? Yeah?
Keep going.
The last one is the last one I mentioned. Is not the last one, not necessarily the last. The My Easy Farm. We liked very much the presentation. It looks very nice. The debate that we had, and was also reflected a little in the questions. First of all, is that there was some uncertainty, some discussion about are we going to look at field level emissions or farm level emissions? And well, you chose the farm level, which included the fertilizer and the fuel aspect, which I think are very important at some stage. But I think you were at this moment beyond the policy interest, at least. Yeah? So that was one of the things. And the forward-looking aspect, it was in the question and answers came back. There is a possibility forward-looking, but that's something that we would have liked to see explored. Because I think that is really something that you can help farmers with, to help them to understand what different choices they make, how they impact on, in this case, carbon, or on biodiversity, or on economics, or all three together. But nevertheless, a good presentation, very nice imagery, pictures and things. Yeah?
Yeah. Wait, but just we have to clap them as well.
Yeah, well, of course. And now?
Yeah.
Oh,
yeah.
Do I continue?
No,
you have to help me, right? So we were told by the organization that there is another prize. And so we all five are back in the box. There's a prize, a special prize, and we decided that we give that to the team that gave us the greatest confidence, coherence, nice presentation, all these kind of aspects of what we just saw here in the last hour. And so we had a big fight about that because there was a lot of discussion, of course, you can imagine. But we came out with a winner. And you want to announce that?
Well, yeah. I mean, it's really interesting seeing how you try to do it, and therefore, I think it is a challenge to put stuff like that together to people like me who don't do coding and stuff in 10 minutes. I think you already did it very well. So again, it's not that there are any big differences, but okay, we decided we would pick one team, and it's again the Capgemini team. We really like it. It's only a small difference, but we decided we would give you guys the prize with it.
Thank you.
That's quite weird. What is this prize then?
What is this prize?
I told you. You have the ability to choose Wageningen University Research Life Sciences hoodies in your own size and your own color. So they will be addressed by this.
Thank you. Thank you. Thanks.
And we expect photos from you.
Okay, one round of applause for the jury. Thank you, guys.
A big prize for you too. Very local, around the corner.
Thank you.
Excellent. Wow.
Enjoy it.
Okay, thank
And
you very
thanks
much.
very much for coming out here and giving a value opinion for.
Okay. My
It was a wonderful thing to do.
Okay, great. And I have one more, and that is for you, Anne. And for Bright, who is always hiding behind.
The chief
organizing this. It was really.
Yeah, so on behalf of the whole organization team, and also I think on behalf of Vicky, that's two ways. Thank you everyone for coming out.
And the remote people.
And all the remote people, almost forgot you guys. Oh no. Thank you for the remote people for being patient and sticking with us and contributing as well to the whole event. Grab a cold drink, enjoy the rest of your Friday afternoon and your weekend. I hope to see you next time. Thank you.
Excellent.
Yeah.